Hi students, so now we will be solving this particular problem from integration. Here we have integration of sec to the power 4x divided by root over tan x into dx. Alright, so roughly you can actually figure out that this will come under the category of substitution. How? Because when you essentially differentiate tan x, you get a sec square x, and somehow we will manipulate the rest of the format. So let's move ahead with the problem. First we will be considering let tan of x equal to t. Once we do that, then we have to take the derivative, which is nothing but sec square x into dx equal to dt, right? Now you might say that I have a sec to the power 4x in the denominator, right? And here only x squared dx will give me a dt. So what about that extra sec squared that I'll be having? So let me make this more clear by breaking the problem first. Like this is sec square x divided by root over of tan x into sec square x into dx, right? I hope you are pretty well aware of the concept of powers, where if we have a multiplication sign between two different two different things, then we have to basically add up the two powers. Here we have a trigonometric function in between, right? So whatever function we have, and if we have a multiplication sign in between, then essentially the powers will get added up, given the fact that this particular function should be the same. Okay, you can't have like sec square x into tan square x, okay, and then you can't write that as sec to the power 4x or tan to the power 4x. Okay, given the fact that the functions are the same, you have to focus on the powers of those two functions, and then what you have to do is see that if there is a multiplication sign in between, if you see a multiplication sign, then simply add them up, and then you see that you get a sec to the power 4x here. These are the very basics you learn in your 6th, 7th and 8th grade. Just in case any one of you is not aware, I told this to you. So what I meant by this is, if you have x to the power 6 and x to the power 6 here, so these two powers will get added up. In the baseline we also have the two functions same, right? X is essentially not a function, you could call it an algebraic function or whatever. Okay, so ultimately these two powers will get added up to give us a x to the power 12. But if I have an x to the power 6 and y to the power 6, then in that case I definitely cannot add the two powers, because the base is not the same. We have an x here and we have a y here. Alright, so now let's come back to the problem. So now what we will be doing here is that in trigonometry, okay, there is a very simple formula, that is 1 plus tan square x equal to sec square x. Alright, so what we have to essentially do here is that we will simply replace this sec square x, 1 sec square x that is left behind, by this 1 plus tan square x. So if I do that, what will I get is like this, and in the denominator I have root over of tan x, and here I have sec square x dx. Now I hope you can understand that this entire problem will get replaced by the variables respectively. So in place of tan square x I can write t square, and in place of root over of tan x I can write root t, and in place of sec square x dx what can I write? dt. Alright. And now that you have come up to this point, I had already told you in the previous videos when I solved different kinds of problems based on proper substitution, that whenever you arrive in these kinds of steps, then what is the first thing that should come to your mind? Just kind of simplify it. How? By separating the form. So essentially what we will be left with is nothing but or write this in the power format, okay? This root t is nothing but t to the power half, right? So when this gets into the numerator, we have a minus half. 1 by t to the power half is nothing but t to the power minus half, and t square by t to the power half is nothing but t to the power 3 by 2. That is 2 minus 1 by 2, right? 2 minus 1 by 2 is nothing but 4 minus 1 by 2 is equals to 3 by 2. That is exactly what I have done here. Simple mathematics, okay? You have to separate these two things, okay? I hope you are getting what I am trying to say. All right, you have to separate these two, okay? And then take the powers in the numerator. In that case, what will happen? The positive power will become a negative, okay? So when it goes up, it becomes t to the power minus half, and when this goes up, this becomes t to the power minus half. And as I already told you, that whenever you have a multiplication sign in between, we have t squared and t to the power minus half, which means both of these powers will get added up. Now this will become like this. Now you know plus minus becomes a minus, so ultimately you will have a 2 minus of half, which is nothing but t to the power 3 by 2. Alright, that is what I have written here. And finally, what you have to do is simply integrate it, and after you integrate it, what you will be getting? T to the power minus half plus 1 is nothing but t to the power half. Minus half plus 1 is half, and there will be a half in the denominator, plus t to the power 3 by 2 is nothing but t to the power 5 by 2 divided by a 5 by 2 plus c. And most importantly, in the last step, the work is all of yours. That is, you have to replace this t by tan of x, okay? So much of explanation is not required for this problem, but I gave this much of explanation in case you were not aware of any of these concepts, all right? Because most of the students might have skipped or forgotten, okay? So this is why, and there are many students as well who remember it. So those who remember it, well and good. Those who don't, then please refer to this video, okay? And watch the entire video, all right? Now after having completed this problem, the last step you will be doing, all right? Please don't forget it. I am leaving doesn't mean that you will leave it, all right? You will replace this t by the tan x, okay? By the function of tan x as originally given in the problem. Our second problem will be, our second problem is nothing but integration of tan of x sec square x divided by a plus b tan square x whole square dx. Here also you can very lightly guess the fact that if I take the derivative of tan square x, then roughly I'll be getting the numerator only, right? Now how will we be getting the numerator? Let's see. I will be considering a plus b tan square of x as t. Now in case I do that, now when I take the derivative of this particular expression, what will I be getting? I'll be getting a 0 here, and in place of b tan square x, what will I be getting? B will remain constant as it is, okay? Constant comes out, and then we will be left with tan square x. Now tell me, how do we take the derivative of tan square x? First, we have to work with the power. So this power comes down and this becomes 2 tan to the power 1x. And then we will take the derivative of tan x, which is nothing but sec square x, right? Into dx equal to dt. So this is the respective derivative that we have. Now, we can also see that here we have a b, so b comes here. Now, in order to get just this particular part which we have in the numerator, we will take 2b essentially in the denominator, okay? So what we will do is we will take this 2b in the denominator, all right? So finally what we will be getting here, we will be getting this tan square x sec square x dx. This entire thing will be replaced by 1 by 2b into dt, and I have this particular thing in the denominator which will be replaced by a 1 by t, right? Is it right? I have a square here, right? So that square I can't miss, okay? So that we have finally come to this part. Next is nothing but simply solving it, which is t to the power, this is t to the power minus 2, right? Let me break it more. So that after integrating, what we will be getting is nothing but t to the power minus 2 plus 1, which is t to the power minus 1 divided by minus 1 plus c. So then my job is to actually replace this t, all right, in the final answer that you will be getting. You have to replace this t by nothing but a plus b tan square x. Please, in some of the questions, I have not replaced it in the final answer. I have asked you to do it. So please get into the habit of replacing this t, else, you know, there is no point in doing the problem, because half of the marks you will lose, because the original problem was actually based on a plus b tan square x, okay, and you did replace it. I told you earlier also that you replaced it by a t for your own convenience, okay. So in the final answer, if the examiner sees that you have written a t and you have not replaced the particular function that was given to you, the particular expression that was given to you, then you might get things wrong. All right, so please do replace these t's that I have in this question and in the previous question also. All right, please do replace these t's by the respective expression that you have taken up. All right, because assumption cannot be your answer. The answer that you have got cannot be based on the assumptions that you have taken, okay. It has to be the original answer based on the expression that has actually been given to you in the question, okay. So if you like my video, then please don't forget to like, share, subscribe and hit the notification bell icon for more of such exciting content. All right, see you in the next video.